In this segment, we'll talk about motion. As a start, try to imagine different types of motion. For example, motion of a car, motion of a bug, some type of animal, motion of the earth around the sun, motion of an airplane. Think of all these motions. Now, when you try to describe these motions, how are you going to differentiate between them? You are going to have to talk about speed, how fast they are moving. You are going to have to talk about where the motion is occurring. How are they moving relative to other objects? At what time the motion is happening? The quantities that we usually use to describe the motion, like I mentioned before, maybe in first thought people are going to think distance, speed, time, acceleration maybe. And as I mentioned in another recording, the quantities that we'll be talking about are going to involve as well what we call position, displacement, velocity, and acceleration and time. Okay, let's start discussing these. Let's start first with position. What do we mean by position? A position like the meaning in English, where the object is at a particular time. Now, to determine the position of an object, like for example, where is Kennesaw? Where's Kennesaw State University? So you have to provide a reference to something, for example, geographic coordinates, latitude and longitude, or you can give its position relative to Highway 75. You might say it is at exit 271 in Highway 75. Now, exit 271, that's measured, the number 271 is going to be relative to the border Georgia has with Florida. That's where the 271 comes from. So whenever we discuss a position, we are going to discuss it relative to a certain reference point, geographical or any other reference point that you can choose. Now, a position is going to involve a length, a distance, and a direction. For example, if we use as a reference Kennesaw State University, and you ask me about the location of the Dunkin' Donuts that's close by. Okay, there is a Dunkin' Donuts in Chastain Road. Now, if I tell you that it is 100 yards away from the entrance from Kennesaw State University, you have two options. You are going to have to go east or west. Now, if I would like to give you the right direction, the complete position, I'm going to have to tell you it's 100 yards to the east. Then you can go straight to that location. If I tell you just 100 yards, I'm not giving you the full direction. Now, the unit is going to be whatever unit that we use for distance, meters, feet, centimeters, millimeters, miles, whatever. And again, the direction is important. Now, whenever a quantity is going to involve both a magnitude, like the distance in this case, and a direction, that quantity is going to be a vector. Usually, to differentiate a vector from a non-vector, if we are going to write a position, let's use the symbol P for example, we put an arrow on top of it to remind us that it is a vector and the direction is important. Now, if I'm going to draw the actual vector P. I'm going to draw it as an arrow, like when we talked about vectors. And the direction, the way the arrow points is the same as the way P is supposed to point. And the length of the arrow is a measure of how big is P. Now, when discussing motion, we are going to start using P for position. To be more precise, sometimes we might end up doing P sub x to try to say it's the position along the horizontal, and P sub y to speak of position along the vertical for objects that are moving up and down. Okay, we'll get back to that later on. Okay, now, after position, we can talk about displacement. What we define as displacement, it is a change in position. That's what we define as displacement. If we think about it in terms of formulas, if we use d as a symbol for the displacement, then the displacement is going to be a final position. The f here is to tell us it's a final minus an initial position. That would be a displacement. Like in all quantities, whenever you take a difference of two quantities, you get a quantity of the same units and of the same type. We have two vectors, so we should get a vector for d, and then both of them have units of meters, so d should have the units of meters as well. Okay, let's try to give examples about displacement and position. Okay, for example, we have this person here at time t1, and then later on here at time t2. So to determine the positions, we are going to choose a reference point, and then we are going to provide the position relative to those reference points. For example, the choice is arbitrary. Sometimes when you have a question, you might be given the reference, but in this case it's not given, so I'm going to choose a reference point. So let's choose as a reference point this point here. That's my reference point. That's my origin. I'm going to measure everything relative to it. Okay, and in this case we need to use some units. So let's say this is about 1 meter, 2 meters, 3 meters, 4 meters, 5 meters, 6 meters. Okay, and then 1, 2, 3, 4, 5, 6, and so on. Now, to the right of the reference, I'm going to designate that as the positive direction. To the left is going to be the negative direction. Okay, I'm not sure why it's not writing. Okay. So now, so what's my position at time t1? So position at time t1, so I put it in parentheses t1, p of t1 is going to be, okay, since it is to the left of the origin, it's going to be minus 2 meters. The position at time t2 it is 1, 2, 3, 4, about 4.7 meters. Or just let's make it simpler. Let's just say 5 meters. Excuse me. So now what's my displacement? My displacement is final position, 5 meters, minus initial position, which is minus 2 meters. So it is actually 5 minus minus 2. So it is, okay, so 5 minus minus 2, that's equal to 7 meters. So my displacement is plus 7 meters, or 7 meters to the positive direction. Now, let's take the opposite case. Let's suppose at time t1 I was at the initial position, at this position. So this is t1. And at time t2, I'm here. So then that's going to change this one to 5 meters. And this one to minus 2 meters. So my displacement is going to be final position minus 2 meters minus initial position, which is 5 meters, minus 2 minus 5 minus 7 meters. Okay? Now in this particular case, my displacement is in the negative direction. So we have two examples here.